Yes? No, you don't have to do degrees, just the radians. Yes. Yeah, when you're done, just keep it there. We're almost done. I can give you another minute. Thirty more seconds. All right, I'm going to come by and pick them up. There we go. I'll come back around if you go for whatever you can do in the next 15 seconds. Yes. Okay. Yes. Thank you. Oops, thank you. Yes.
I don't remember that being passed around on Tuesday.
I didn't pass it around. Yeah, I forgot. So it's coming around this time. I forgot last time. It's yours. Okay. All right. Take what you have. Thank you. Anybody else? Okay. Take what you have. All right. So, yeah, I'll get those grades in. Any questions before I begin? Yes?
It says on the homework today was at 1 p.m.
Today?
Yes.
Uh-huh. But I said not to finish all the problems, right?
Yeah.
Okay. So after today, I'll go in there and reopen it. I think you can get to it anyway, even after the due date. But I'll reopen it so you can finish up the problems from the end of the section. Yes?
I noticed on one of them, it said it was still open after the due date, but it said it was minus 20%.
Oh, it was a deduction? Okay, I'll extend that so that you don't get penalized. Oh, it didn't let you change the answers?
I was able to, I was able to, I think it was, what was due today, 7.2?
7.2.
Yeah, I was able to do 7.1. And I was doing Thursday, and I did it yesterday.
But with the penalty?
Yeah,
All right, I'll go back and change it. Any other issues or questions? No? Okay, so we didn't quite finish 7.2 last time, but we did establish all 6 trigonometric functions, right? Sine, cosine, tangent, all those things have been established. And all of it is based upon what we call right triangle trigonometry. So we have a triangle that has one angle that's 90 degrees, right? And the other two can be anything. Well, not anything. They have to both be less than 90 degrees. But we call this one, let's say, theta. And let's call this one over here, we'll call it beta. All right? What can you tell me about theta and beta together, those angles added together? They have to be 90 degrees, right? So we know that theta plus beta must be 90 degrees. Or another way you could say that is that theta plus beta must be pi over what? 90 degrees is equivalent to what in radians? Pi over 2, all right? So if we're referring to these two angles, theta and beta, in terms of degrees, these two angles have to add up to be 90, right? Because 90 plus these two, 90, that'd be 180, which is what we need for a triangle. Okay, anytime this happens, all right, anytime two angles add up to be 90 or pi over 2, we call them complementary angles. Right? Complementary angles add up to be 90 degrees or pi over 2. So in this case, theta and beta are complementary angles. All right, so now what I'm going to do is I'm going to label this triangle, and I'm going to ask you some things from last class. Remember SOHCAHTOA, right? So let's call this side here A, let's call this side here B, let's call this side here C. What would sine of theta be in terms of a ratio of sides? What is it? Which side over which side? Opposite over hypotenuse. So in terms of that triangle, sine of theta would be B over C, right? B over C? We good? All right. But what is, if that's right, then what is cosine of beta? So look at the triangle, right? I'm asking you for cosine of beta. So this is beta, right? This is theta, this is beta. So if you look at the triangle, you kind of have to maybe like turn your head sideways a little bit. And then this would, A would be which side? Opposite, right? That's the opposite side of beta. And the B would actually be the adjacent side to beta. And then C would be still the hypotenuse. Do you all see that? If I change from theta to beta, then your reference is a little different. So what would cosine of beta be? It'd be B over C as well, wouldn't it? This is also B over C. These are the same, aren't they? So what we can deduce from this is that sine of theta is equal to cosine of beta so long as theta and beta are complementary angles. Right? So if they're complementary, so the picture looks like this, then that should always be true, shouldn't it? Do y'all see that? I'm going to box that. Now, let's look at something else. I'm going to leave that over there. Let's erase this. I'll leave that for now. Let's talk about cosine of theta. What's cosine of theta? So go to this triangle. That would be which side over which side? A over C, right? A over C. All right, now in terms of beta, can you all tell me which trig function would give you B over C? But in terms of beta, I mean, sorry, not B over C, A over C, would give you this and this. Sine, right? Sine of beta. Sine of beta would give you opposite over hypotenuse, right? Yes or no? Yes? So sine of beta would be A over C as well. So we could deduce, let's add it to this over here, that cosine of theta is sine of beta. So long as theta and beta are complementary angles. Following? Where do you think I'm going to go now? Tangent. Let's talk about tangent. So what is tangent of theta? Well, let's see. Tangent of theta. Here's theta. Tangent of theta, SOHCAHTOA, OA, opposite over adjacent. So it's B over A, right? B over A. can you think of which trig function, which trig function of beta would give me the same ratio b over a? So I'm asking you right here, what trig function, sine, cosine, what are all the trig functions? Sine, cosine, right? Tangent, cotangent, secant, cosecant, all those different ones, right? So which one of beta would give you the same thing, b over a? It'd be adjacent over opposite, right? For beta, b over a would be adjacent over opposite. Which trig function is adjacent over opposite? I heard it. Someone said it. Cotangent. It's the reciprocal of tangent, right? Tangent is opposite over adjacent. Cotangent would be adjacent over opposite. So this would be cotangent beta. So these two are the same. So I'm going to add it to this list over here. So cotangent, tangent, this is what I want to write. Tangent of theta is equal to cotangent of beta, so long as theta and beta are complementary angles. All right. So let me give you a specific example. This is the general scenario. All right. Let me give you a specific triangle. And let's just say that I tell you that we have this triangle, right triangle, all right? And let me say that this is 25 degrees, right? And let's call that theta. Then can you tell me what the other angle is? What is it? 55 here? 65. 65? How are you doing that? How are you figuring out this angle? You take 90 degrees and you subtract 25 degrees, and that gives you 66. 65, right? So that would be the other angle. This would be, let's call it beta. Right? So using these three things, what could we write down? What does this first equation say? Sine of 25 is equal to what? Cosine of 65, right? It's equal to cosine of its complementary angle. Similarly, cosine of 25 degrees should be equal to what? Sine of 65. And then finally, tangent of 25 degrees should be cotangent of 65 degrees. So what I'm trying to establish here is what's called in your textbook the complementary angle theorem. It just says that, look, there is a relationship between sine and cosine and tangent and cotangent. There's a relationship between these two if we're talking about complementary angles, right? That we have some relationships that are always true. So what they do next, okay, is they say, all right, let's act like we have a triangle, all right? See if you can follow this. So I know as students, sometimes when they see this, they're like, okay, this is confusing. Let's say we call this theta, all right? And I'm not going to give you what the angle is. Do you all agree that this angle, we could call it beta, couldn't we? But let's not call it beta. Do you agree that that angle, whatever it is 90 degrees minus whatever theta is? Yes? So what would this equation look like, this first one, what would it look like if I wrote it down in terms of that triangle? It would be sine of theta equals cosine of what? Beta, but we're not calling it beta, we're calling it 90 minus theta, right? So I'm going to write it like this. I'm going to put it in parentheses so that you realize this is all sitting inside of here. So sine of this angle is equal to cosine of that angle, right? That's basically the same. This is the same thing, except we're rewriting beta as 90 minus theta. Does that make sense to you? Yeah? And then the rest of them, you could fill out the rest, right? Cosine of theta is sine of 90 minus theta. And then lastly, tangent of theta would be cotangent of 90 minus theta. Now in your textbook, let me see if I can find this. Where's the zoom on this damn book? Can you zoom? Yeah, there we go. In your textbook, that's where they summarize everything. They do it in a table. So look at the see how they separate it into degrees and then radians? Do you see the top left? Sine of theta is cosine of 90 minus theta. And then work across the top. The next one is cosine theta is sine of 90 minus theta. And then the last one on the top, tangent theta, is cotangent 90 minus theta. Right? Do those formulas now kind of make sense to you, where they come from? And then what is the next line? The one here, cosecant, secant, secant, cosecant. Those are all just the reciprocal functions, aren't they? So that kind of makes sense, I hope. And then what are all these? Because these look totally different, or are they the same? They're the same, except instead of using 90 degrees, we're using pi over 2 for radians, right? So these are what we refer to as, these are kind of like our first trigonometric identities. These are things that we should be, it's not like you have to have all these memorized. You just need to know that they exist. And then on a test, you would be allowed, I would provide you with a reference sheet so that you could reference these, which we'll talk about because we have a test, what, next week? Tuesday is our first test. So we need to, by the end of today, we need to talk a little bit about the test for next week. All right? What you can have, what to expect, am I going to give you a review, all that sort of stuff, right? All right, any questions on this concept? All right, we're going to move into the next section then. So we're going to move into, what is it? 7.3. So 7.3 is called computing the values of trig functions. Computing the values of the trig functions for acute angles. Remember that an acute angle is an angle that is smaller than 90 degrees. So right now we are restricting ourselves to just angles that are less than 90 degrees. That way we can visualize this as being that triangle, the right triangle. Right? Because all the angles in a right triangle have to be less than 90. All right, so how do we compute the values? So let's do this. If you think back to last class, what I did last class, if you look in your notes, is I gave you some information, right? So I'm going to ask you just to recall so we don't confuse this with what we're doing today. Recall, last class what I would do is I would do this. I would say if I told you that sine of theta was 4 over 7, go find all other trig values, right? And that's what you did in your homework. And you would draw a triangle, right? And then you would use Pythagorean to find the missing side, and then you create all the answers, right? But I provided you one of the trig functions. I provided you sine of something or cosine or tangent. I had to give you this, and then you would go do it, right? This is different, what we're doing today. Instead, what I'm going to do is I'm going to provide you with an angle, And I want you to give me all the 6 trig functions based on that angle. So it's a very different approach or different sort of method of what we're trying to do, right? So that's what we did. Today, I'm going to do this. Today is this. If I tell you that theta is, let's start with a nice angle. If theta is 45 degrees, I want you to find all 6 trig function values. Y'all see the difference between last class and today? Right? So I'm going to give you an angle, and then you have to go find all the value of sine, cosine, tangent, all of them, right? So how are we going to do this? Let's see. Let's start doing it. So I have an angle of 45 degrees, right? I'm going to draw a right triangle. Let's just do this one right here. If I tell you that this is 45 degrees, then what's the other angle? 45 as well, right? Both of these angles are 45. And so let's just start with sine of theta. Sine of 45 degrees. If I'm asking you for sine of 45 degrees, then what I'm saying is look at this right here, this angle, 45. Sine is which side over which side? Opposite. So I want you to take this opposite side and divide it by the hypotenuse, right? Right? I want you to take the opposite side of this triangle and divide it by the hypotenuse and tell me what the answer is. But see, I didn't give you the sides, did I? I did not give you the sides. But one of the fundamental things that we learned last class? Yeah, it was last class. One of the fundamental things that we learned is, from last class is this. If I draw a triangle with a certain angle like this, and I tell you this is 45, that if I then draw a bigger triangle with that same angle, remember I said that the ratio of this side divided by this should be the same as this side divided by the whole thing. So it doesn't matter how big you scale this triangle up, the ratios will always maintain the same, you'll always have the same ratio regardless. Which means that if I'm going to try and solve this problem, I get to label these sides however I want to label them. I have that freedom because it doesn't matter how big this triangle is as long as this angle is 45. So now that I have that freedom to label this however I want to label it, I get to choose how do I label it. So can anybody kind of tell me if this is 45 and this is 45, can anybody tell me what the relationship between these two sides is? They have to be the same. Do you all buy that? If these two angles are the same, then whatever this side is, that side is. So I'm just gonna call it something. I'm just gonna give it a value. How about we just say that's 1? And that would mean that's 1, right? And so to do sine of 45, all I need is the hypotenuse now, don't I? Which should be easy to get using the Pythagorean, right? A squared plus b squared is c squared. So if we label this side c, Pythagorean tells me that 1 squared plus 1 squared is c squared. What's 1 squared plus 1 squared? 2 equals c squared. And now what's c then? Square root of 2. Right? So that means this side is square root of 2, right? Now can you tell me what sine is? Sine of 45, sorry. What's sine of 45 degrees? 1 over the square root of 2. Right? And that should work for any triangle that has a 45 here, shouldn't it? Yeah, it should. Now, this is not the way you're going to see it in a textbook, and this is not the way you're going to need to memorize it here. We are going to rationalize the denominator. Now, we had this big long talk. Do you have to rationalize? No. Should you know how to do it? Yes. All textbooks, well, yeah, every textbook I've ever seen has never left this like this. Sine of 45 is 1 over root 2. They multiply the top and bottom by root 2. So even though that's correct, we can multiply by root 2 on top and bottom, and we get what you'll see in all textbooks, square root of 2 divided by 2. So sine of 45 degrees is this. Do y'all understand where I got that? Root 2. Root 2 times root 2 is 2, right? Yeah. So sine of 45 degrees is the square root of 2 over 2, regardless of what universe you live in, as long as you're talking about Euclidean geometry. Like that's what sine of 45 degrees is. Yes?
So what would it be if one angle wasn't 45?
Yeah, we're working towards that, right? If this angle's 45, does everyone agree that one has to be 45? Okay, because they're complementary. Right, they all have to add up to be 180. So yeah, I think your question is, what if this is 40 degrees, right? Then what's sine of 40 degrees? That's a different question. Right now, I'm working with the ones I'm going to be able to show you visually. I picked this number 1 arbitrarily, didn't I? I picked it arbitrarily. What if you decided to do the problem, and you said, you know what? I don't like the fact that you used 1. I want to use. What do you want to use? 5. What if you said you wanted to use 5? Are you going to get the same answer as me? Yes. Let's see. Let's see what happens. If this is 5 and this is 5, we have to agree that both sides have to be 5 because it's 45 degree. 45, 45, these sides are the same, right? Are we still going to get sine of 45 is root 2 over 2? Let's see. Well, we need to get this side, don't we? C? So to get c, you do this squared plus this squared is that squared. 5 squared plus 5 squared is c squared. 50 square root. That's c, right? So this is the square root of 50. All right, now based upon this picture, what's sine of 45 degrees? It's 5 over the square root of 50. Are those the same answers? They don't look the same, but they are. Let's see why they're the same. Let's do the rationalize. Okay, let's multiply the top and bottom of this by what? Root 50. Okay. What would happen here? Up top we have 5 root 50. And on the bottom we have what? 50. Don't this 5 and 50 reduce? Right, I can go 5 goes in here once, 5 goes in here 10 times. So now I have this. Top is just root 50 over 10, right? These still don't look the same, do they? Until you realize that the inside, the 50 can be broken down, can't it? This 50 can be broken down to be root 25 times root 2. Isn't that the same as, that's what root 50 is up top? And then that's just a 5. I'm almost there. 5 over 10, here's root 2, right? And the 5 and the 10 reduce out and you get root 2 over 2. Right? You get the same exact ratio. That's what I'm trying to drive home here. Sine of 45 degrees is always square root of 2 over 2, regardless of how you ever draw your triangle. As long as this is 45, well, that forces that to be 45. Then these two sides have to be the same. And then no matter how you get the hypotenuse and reduce everything out, you're always going to get that as your answer. Always. All right? Now, 45 degrees is actually one of our common angles, right? Like when we were looking at angles, the quiz you just did, that was this angle right here, right? That was that 45 degrees. So now we know what one of the trig function is for that, right? All right. What's cosine of 45 degrees?
Root 2 over 2.
Why?
Because the sides are the same.
Okay, so if we now ask what's cosine, there's a couple of different ways you can say this. If we now say what's cosine of 45 degrees, You're saying it's the same y?
Because the opposite and adjacent are equal, so the ratio should be the same.
Yeah, so if you do cosine of 45 degrees, here's our picture, right, that we built this off of. Cosine is this side over that, right? Instead of opposite over hypotenuse, it's adjacent over hypotenuse, but that's the exact same number. That's the same calculation. It's 1 over root 2, right? It's 1 over root 2, which is root 2 over 2. Where's that thing over there? Could we have used this right there? Top left corner. Sine of theta equals cosine of 90 degrees minus theta. Could I have made the same argument using this? Sine of 45 equals cosine of 90 minus 45 is 45. So isn't this saying that they're going to be the same answers? You could have made your argument this way, or just worked off the triangle and said, oh, opposite over hypotenuse is exactly the same as adjacent over hypotenuse for this triangle. All right. So we have two major things here that you're going to burn into your brain. Sine of 45 degrees is root 2 over 2, and so is cosine of 45 degrees. It's also root 2 over 2. What's tangent of 45 degrees? Soka toa. This picture. It's opposite over adjacent, right? So look at your picture. Here's our picture. Opposite over adjacent is? 1 over 1 is 1, right? In the other triangle I drew, wouldn't it have been 5 over 5? Yeah. Still 1, right? So tangent of theta is, or sorry, not tangent of theta. Tangent of 45 is 1, always. All right? I put it up here too. Tangent of 45 degrees is 1. Sine of 45 is root 2 over 2. Cosine of 45 is also root 2 over 2. Right? Those are three trig functions at one angle that we all are familiar with, 45 degrees. What about the other three trig functions? Like how about cosecant? What's cosecant of 45 degrees? It's this one flipped, isn't it? Cosecant is the reciprocal of sine. So isn't it this flipped over? Right? Okay, well let's flip it over. That's 2 over root 2, right? That's not the way they're going to put it though, right? Because they don't like the radical in the bar.